Dear students, welcome to another video tutorial on data structure and algorithm. And today's topic is Doubly linked list. Okay. So myself Niladji Shekhar Pal. I am working as an assistant professor at Computer Science and Engineering Department at Greater Kolkata College of Engineering and Management. The college is under JIS group. Okay. So what is double linked list? Double linked list basically is a collection of nodes linked together in a sequential way. Each node of the list contains two parts. One is data part and another one is the reference part or address part. The basic structure of node is shown in the below image. Okay. So as you can see that this is the data part, this is the address of the previous node, and this part is the address of next node, and the complete part is called the node. Okay. So double linked list is almost similar to single linked list, except it contains two address or reference fields. Okay. So double linked list is basically similar as the single linked list. Okay. The only difference is that it has two address part. Okay. In the single linked list, it only holds the address of the next node. Okay. But in case of double linked list, the node already also holds the address of previous node and also the address of next node. Okay. So double linked list is almost similar to single linked list. Okay. Except it contains two addresses or references fields, where one of the address field contains reference of the next node and other contains reference of the previous node. First and last node of a linked list basically contains a terminator, generally a null value. Okay, as we know that the first node and the last node basically contains the null. Okay, in our single linked list, only the last node contains the null. Okay, as it defines that there is no node after that. But in case of double linked list, as it also linked the previous node. Okay, so at the previous node at the first node in the previous part also hold the null value that determines the start and the end of the list. Okay. Double linked list is sometimes also referred as bidirectional linked list, since it allows traversal of nodes in both the direction. Okay. So double linked list is sometimes also called as bidirectional linked list, since it allows traversal of node in both directions. Okay. So we can start from the beginning or we can start from the end also. The basic structure of a double linked list is represented as like this. Okay. So as you can see, this is the head and this is the last. Okay. These are the elements. Okay. So these are the elements. Okay. So 10, there is no node before it. Okay. That is why this is null. And after 40, there is no node. That is why this is the next part is null. This is called the previous part and this is called the next part. This is previous, this is next. This is also previous, this is next. This is previous, this is next. Okay. So next part of last node is null and previous part of first node is also null. Okay. So as you can see that this is bidirectional. From 10 to 40, we can move from 10 to 40 or from 40 to 10 also. This is the structured part. Okay, how to create a node. Okay, how to define a struct of node. Okay, this is struct node, int data, struct node pointer print. Okay, this is struct node pointer next. Okay, this is the previous. Okay, this is the address of previous node and this is the address of next node. Now, what are the advantages of double linked list? As single linked list, it is the easiest data structure to implement. Okay, it allows traversal of nodes in both directions, which is not possible in single linked list. Deletion of nodes is easy when compared to single linked list, as in single linked list deletion requires a pointer to the node and previous node to be deleted, which is not in case of double linked list. We only need the pointer which is to be deleted. Reversing the list is simple and straightforward. Okay, in case of double linked list, can allocate or deallocate memory easily when required during its execution. It is one of the most efficient data structure to implement when traversing in both directions is required. What are the disadvantages and applications? It uses extra memory when compared to array and single link. Sorry, will be the disadvantages. Okay. So it uses extra memory when compared to array and single linked list. Since elements in memory are stored randomly, hence elements are accessed sequentially. Okay, so no direct access is allowed. What are the applications? Double linked list can be used in navigation systems where both front and back navigation is required. It is used by browsers to implement backward and forward navigation of visited web pages, that is back and forward button. Okay. It is also used by various applications to implement undo and redo functionality. It can also be used to represent deck of cards in games. Okay. So what are the steps to create and traverse? Step 1. Create a head node and assign some data to its data field. Step 2. Make sure that the previous and next address field of the head node must point to null. Step 3. Make the head node as last node. As you can see that at first these are all null. Okay. After that we will create another node and connect these nodes to the other node. Okay. So now we will do a C program which will create and traverse double linked list. So let's do the C program. So this is the editor, new source file. Okay. So we'll write our program here. So at first we will take the hash include statement. Okay. Sorry, hash include stdio.h. After that hash include convert.h. Okay. Then int main. Sorry, before that we will define the structure. Okay, globally. Struct node. Okay, struct node int data. This is the data part. Okay, and next we will take the previous and next part. Okay, so struct node pointer prev. Okay, and after that struct node pointer next. Okay, so here we will take two parts. One is the head and another one is the last. Okay, here we have two parts. Next we will take the all the functions. Okay, first function is void create list. This is int n. A value will be the size of the linked list. Okay, next void display. Okay, we will display the list from first. Okay, from first. Or we can display list from last. Okay. So after that, this is the int main function. Okay. So we will take two variables int n and choice. Okay. After that, head equals to null and last equals to also null. Okay. So printf enter the number of nodes. Okay. So the number of nodes will be inserted. Scanf percentage d comma ampersand n. Okay. After that, we will call the create list function. So value of n will be passed. Okay, that means what is the size of the linked list. Okay. Next, printf press 1 to display list from first. Okay. Next, printf press 2 to display list from last. Okay. So next, scanf percentage d and percent choice. Okay. So if choice is 1, then we will call the create list first. Okay. So we call the function display list from first. Okay. Else or else if. Okay. As we have used press 2, okay, that is why we take else if. Okay. Else if choice equal to, we can say that display list from last. Okay. Otherwise there will be return 0. Okay. So now we will call one by one, or we can say that we will define all the functions one by one. Okay. So void create list. Okay. So we'll take the I and data to variables. Next we'll take a node, struct node. And next, if n greater than equals to 1, okay, we can write that head equals to struct node pointer malloc size of struct. Okay. So if head equals to null, okay, so if head not equals to null, okay, we can take the data, okay, slash enter data of last node. Okay. Next, there is a scanf statement, percentage d, comma, ampersand data. Okay. After that, data equals to data. Okay. Head of previous will be null. Okay, at first all are null, and head of next will be also null. And last and head are same. Okay, as there is only single node. Next, I will take a for loop for I equals to 2, I less than equals to n, I plus plus. Okay. So new node equals to struct node star. Okay. Malloc. This is size of struct node. Okay. So if node equals to null now, okay. If node equals to null, then what will happen? So if new node not equal to null, okay, you can say that printf slash n enter data of percentage d node. Okay, the value will be I. So scanf percentage d comma ampersand data. Okay. So new node data equals to data. New node previous equals to last, and new node next will be null. Okay. New node next will be null. Okay. And here we will link previous node with the new node. Okay. So last next equals to new node. Okay. And now we will make new node as last previous node. Okay. So last equals to new node. So in the else part, we will printf unable to allocate memory. Unable to allocate memory. And that as a break statement. Okay. there is a break statement. So here we will just giving a printf that we have already created successfully like this. Okay, so doubly linked list created successfully. So in the else part we can write that printf unable to allocate memory. Okay, unable to allocate memory. Okay, so now there is an extra backup. So now I will display the content of the list from beginning. Okay, so this is here we have already created the linked list. Okay, double linked list. Now we'll display it from first, and after that we will display it from the last. Okay, so at first we will display it from first. So why display list from first? Okay, so struct percentage 10 int n equals to 1. Okay, so if head equal null, we can say that printf list is empty. Okay. So in the else part, we can say that temp equals to head. Okay. Next printf slash data in the list. So while temp not equals to null, printf data of percentage d not equals to percentage d. Okay, so comma 10 comma 10. So 1 plus plus next temp equals to temp next. Next we will define another function, that is void display list from a. So struct 10 int n equals to 0 if last equal null, printf slash list is empty. Okay. The else part temp equals to last. Okay. So you can printf that slash data in the list. Okay. So there is a while loop. While temp not equals to null, we printf the data of last percentage node equals to percentage d. Okay. L n temp data. So n plus plus. And after that, temp will be 10 previous. Okay, as we are moving from last to first. Okay. Okay, so this is the code. Now we will save it, save as, and the desktop simplify doubly linked list. Okay, double linked list. Dot C. Okay. Now we'll run it. So now let's execute the program, compile and run. Okay. So enter the number of nodes you want to create. Suppose it is 4. So the number are suppose 5, 10, 15, and 20. So double linked list has been created. Now we'll want to see it. Maybe see one from beginning or from end. Okay. If we want to see it from last, it will be 2. So as you can see, 20, 15, 10, 5. Okay. So again executing my program. So the number of nodes, it is again 4. Enter total data is 4, 5, 6, 7. So 1. So as you can 4, 5, 6, 7. Okay. So this is the code for linked list. Okay. These are the codes. This is the code. This is the function. Another. Okay. So students, this is the C program to create and traverse doubly linked list. Hope you have understood. If you have any doubt, any query, you can write on the comment section of the video, or if you have liked my video, you can subscribe to my channel or of you visit www.facebook.com/digitalclassroom and like my page. Okay. So students, thank you for now. See you on the next video tutorial. Thank you.